In this PowerPoint, I'm going to go through a topic called harmonic form, which is part of the trigonometry chapter. So first of all, see if you can sketch these four different graphs. Y equals cos of x, y equals 4 cos x minus 90, and then the bottom one in blue is 3 sine of x plus 4 cos of x. So press pause now and just spend a couple of minutes seeing if you can sketch those four graphs. Press pause now. On the next slide, I'll show you the answers. So I'm now going to show you the four graphs. The first one's very easy. Everyone should know that first graph. The cos graph starts up at 1, goes down to -1, does a full turn in 360 degrees, and obviously it would carry on forever and ever. So you could mark off a couple of important numbers. The second one, 4 cos of x, is very similar. The only real difference is that instead of going up to 1 and down to -1, this one goes up to 4. Excuse me, 4 and -4. So it's just a taller graph. It's been stretched in the y direction. Okay, the next one. This one's also 4 cos of x, but it's got a -90 in that bracket, which means that the graph needs to be shifted 90 to the right. So it ends up looking like this. It still goes up to 4 and down to -4. The amplitude is still 4, but I've shifted the graph to the right 90 degrees, so it actually starts from the origin. Okay, the last one, 3 sine of x plus 4 cos of x. That was a bit of a trick question really, because I'm not really expecting many of you to know what that looks like. You could draw the separate graphs of 3 sine x and 4 cos x together and then try and add them. But that's actually quite tricky to do very accurately. I'll show you on the next slide what I mean. So here, in two different colours, I've drawn the two separate graphs, 3 sine of x plus 4 cos of x. So we could work our way along the graph and just add the two values together. So for example, at 0, the blue graph's at 0, the red graph's at 4. Well, 0 and 4 is 4, so I know it's going to start there. At 30 degrees, the blue graph is on about 1.5 roughly. The red graph is on about 3.5, so if we add those together, 1.5, 3.5 is about 5-ish, so it would be about right there. And we could keep doing that at different points along the graph, adding together the blue and red coordinates. So at 60, it looks like the red graph is on about 2.5. The green graph also looks like it's on about 2.5. So that would be one way of getting a good guess what the graph looks like. But obviously that's not particularly accurate. It's not the best way of doing it. So I'm now going to show you a method called harmonic form. I also call it the R alpha method because we use the letters R and alpha in the method. And what it does is it allows us to write something like this, which has sine and cos, in a different way, so that it doesn't have sine and cos, it'll just have one trig function. So that's the idea with the R alpha method. We want to try and write something that has sine and cos just in terms of sine or just in terms of cos. So for this one, what we're going to do is we're going to try and write that equation in the form R cos of x minus alpha, because if we can write it in that form, it'll be much easier to sketch the graph, because we know what a cos graph looks like. We know if there's an R in front, that just means that we go up to R and down to minus R on the y-axis. And then whatever alpha is, we know that that just shifts the graph to the right for a negative alpha, or to the left for a positive alpha. So that's the beauty and the idea behind writing it in this form. Okay, so let's get working on this. We're trying to write 3 sine of x plus 4 cos x in this form, R cos of x minus alpha. So first of all, let's have a look at that R cos of x minus alpha. and see what we can do with that. I'm hoping that you remembered that there's a formula in the formula booklet that will allow you to expand this. It's the cos of A minus B formula. So if we use that cos of A minus B formula from the formula booklet, it's cos of A cos of B plus sine of A sine of B. Now for us, that's obviously cos of X cos of alpha plus sine of X sine of alpha. But this also has an R in front. So we need to times everything there by R, so you can see both of those R's. Now going back to the question, we wanted to write this 3 sine x plus 4 cos x in this form. So let's write them equal to each other. And then you could swap those two terms over if you wanted to. You don't have to do that. The reason that can be helpful is because now on the left we've got our sine x's and then our cos x's, and on the right we've got our sine x there and then our cos x there. Okay, so this is as far as we got on the last slide. 3 sine x plus 4 cos x equals r sine alpha sine x plus r cos alpha cos x. Now the next thing we're going to do is to compare how many sine x's are on the left and the right, and then we'll compare how many cos x's are on the left and the right. Let's start with the sine. So I've circled the terms for the sine x's. On the left I can see that there are 3 of them. The coefficient is 3. And on the right, sine x is being multiplied with r sine alpha, so that's the coefficient. So we could write that as a little equation. However many sine x's there are on the left, it must be the same as the number of sine x's on the right. So 3 must equal r sine alpha. Next we could do the same thing with the cos x's. However many cos x's are on the left must be equal to however many there are on the right. So on the left there are 4, and on the right there's r cos alpha. So we could write this little mini equation. So we've now got 2 equations. You've spotted, I'm sure, that they both have 2 letters in them, r and alpha. And 2 equations with 2 unknowns can only mean one thing: simultaneous equations. So here are our 2 equations. We're going to now solve them as simultaneous equations. The trick with this one is to divide them. Dividing them is really helpful because the r's will cancel out and sine over cos is tan. So we end up with tan of alpha equals 3/4, and then obviously from your calculator you can do shift tan of 3/4 to get your alpha value. Now you might be thinking, let's sub that alpha value back into one of my equations to work out r. And you could do that, but when you do that, you don't always get the exact value of r. Quite often r is a surd, and you don't always get the exact value by subbing alpha in. So I'm going to show you a different, better method that you should always use. So instead of subbing alpha in to one of those equations, a better strategy would be to add the squares of the equations. Square them both and add them together. Now that might seem a little bit odd to begin with, but in a minute you'll see why that's such a good idea. So I've squared them both and added them together. So the top one, 3 squared is 9, and then 4 squared is 16. But the right hand side, so if we square those, we'll have r squared sine squared alpha and r squared cos squared alpha. On the left hand side then we've got this common factor of r squared. And if we factorise that out, you've probably now spotted why this is really clever, because in our bracket we've got sine squared plus cos squared, which always equals 1. So actually that bracket can totally be ignored because it's just a 1. So we've got r squared equals 9 and 16, which is obviously 25. And if we square root, we work out the exact value of r. So r is exactly 5. If you'd subbed your alpha in earlier, you might not have got that exact answer. So this is a better method that you should definitely use. So putting all that back together, remember that we were aiming for r cos of x minus alpha. Well, we now know that r is 5, so we can put that in. And we now know that alpha is 36.9, so we can put that in. So we end up with 5 cos of x minus 36.9. So if you did want to sketch the graph of it, it's much easier to sketch it now that it's in this form, because we know what a cos graph looks like. We just need to stretch it so that it goes up to 5 and down to -5. And we also need to just shift it 36.9 across to the right. So this is a graph. This is what the graph would look like. So next I'm going to go through an example where instead of writing something in the form r cos of x minus alpha, I'm going to write it in a different way. This time we're going to aim for r sine of x plus alpha. So this is the one that we're going to do. We're going to start with 3 sine x plus 2 cos x, and we're going to try and write it in the form of r sine of x plus alpha. Now it starts off in exactly the same way as when we were doing our cos of x minus alpha. So the first thing we do is we expand this using the addition formulae. So from the formula booklet, we use the sine of a plus b formula to expand. So it becomes sine x cos alpha plus cos x sine alpha. And then obviously we've got a times by an r, because we want that r in front. So we end up with these two terms. And now we compare the question with how we want to write it. So the question was 3 sine x plus 2 cos x. So we compare that with our expansion. If we look at the sine x's, there's 3 of them on the left, and then r cos alpha of them on the right. With the cos x's, there's 2 on the left, and then r sine alpha on the right. So we end up with those 2 little mini equations, and we'll solve them in the same way as before. So we can divide them first of all. If we divide them, the r's will cancel out. Obviously you need to make sure you write the one with the sine on the top so that you can say sine over cos equals tan. And then you can do shift tan on the calculator to get an alpha value. Next, remember that we're not going to sub alpha in. The better method to do would be to square the equations and add them together. Because if you square the equations, you get a cos squared plus a sine squared, which equals 1. So that's the same method as earlier, and this time r has turned out to be a third. Now if you'd subbed your alpha value back in, even if you'd used the full number on your calculator, it's very unlikely that you would have ended up with the exact value of root 13. So that's why this method is so useful. So putting all of our answer together, we wanted to write it in the form r sine of x plus alpha. We've worked at r, we've worked at alpha, so we can put them in, and we've got our final answer. So now you can see that the graph is much easier to draw. When it was a mixture of sine and cos, that was really tricky to draw, but now that it's just a sine function, it's much easier to draw. We need to draw a sine curve. We need to stretch it so that it reaches root 13 and goes down to minus root 13. And then we also need to shift it a little bit to the left, because it's plus 33.7 in the bracket, so we move it to the left a little bit. And there you can see the picture of the graph. Something else that's really important on this topic is that the examiner might not always tell you how to write the expression. There are 4 possible ways of writing something like this. R cos of x plus alpha, r cos of x minus alpha, r sine of x plus alpha, and r sine of x minus alpha. And I've just gone through 2 of those 4, but they all work in very similar ways. And if you're told which one to use, then that's obviously great. But if the examiner doesn't tell you which one to use, you are going to need to try and choose yourself which is the right one to use. Sometimes 2 work, sometimes only 1 works, but it's really important that you know how to make the choice. So for this one, if we look at the question, it has a negative in it, so we're looking for an addition formula that has a negative in it. And these two formulas here have negatives in. So the sine of A minus B formula from the formula booklet has a sine x cos alpha and then a minus cos x sine alpha. So that has the minus sign in the middle. The other one that would have a minus would be cos of A plus B, which is cos cos minus sine sine. So we've got those two to choose from. But putting a little bit more thought into it, which one matches it best? Well, yes, we've got a minus sign in the middle, but look where the minus sign is. It's attached to the sine x. So what we really want is the one with a minus sine x. The top line has a minus cos x, which we don't really want. We want one with a minus sine x, so this is the one that's a better choice. So the second one has the cos x and the sine x in the right places, so that's the right one to use. Once you've decided which one you're going to use, you know how to write it in that form, so I'm not going to go through this in detail, but perhaps you could press pause and have a look at this method. It's the same method that we've seen a couple of times, and we end it with that answer. So if you need to slow down and have a look at that, press pause now to go through those workings. So the next thing we're going to do is use the R alpha method or harmonic form, not only to just solve, to plot a graph, but to solve an equation. So if you have a look at this one here, we've got sine of x plus 2 cos of x equals 1. And we can use this harmonic form method to solve that equation. Because if we wrote the left-hand side in the form of r cos of x minus alpha, then it would make it much easier to solve. So the first thing to do, which I won't go through in detail because we've done a few now, is to write the left-hand side in the form r cos of x minus alpha. So there are the workings, how to get the form. And it turns into, r turns out to be root 5, and alpha turns out to be 26.6. So the left-hand side is 5 cos of x minus 26.6. And then in the question, it had equals 1, so if we put that as equals 1, and now we can move on to solve that equation. So here's the equation to solve. So first of all, you could move your root 5 over to the right-hand side, so that becomes 1 over root 5. And then, of course, we could do the inverse cos of root 5, and we get an answer of 63.4. Now, remember that that's what x minus 26.6 is. So we're going to have to add the 26.6 over onto the 63.4. That will give us a final x value of 90. Now, to get the other x value, what I recommend you do is you draw your cast diagram, but use the 63.4 value. So I could put 63.4 into the cast. Remember that cos was a positive number, so I'm looking for the quadrants where cos is positive. So I could do 360 take away 63.4, which is 296.6. So earlier on, after I'd done the inverse cos, x minus 26.6 turned out to be 63.4 or 296.6. So now, onto each of those, I need to add on the 26.6. So if I add 26.6 onto 63.4, I get 90. Or if I do 296 add 26.6, I get 323.2. So my final answers are 90 and 323.2. So even though this stuff in the box here is correct, I tend to do the cast diagram as soon as I've done an inverse cos, get a load of possible answers, and then add 26.6 onto all of them at the same time at the end.